Hey everyone, so we are going to be kicking off this live stream shortly. If you're joining though, if you could please leave a message in chat, just say hello and let us know what kind of tools that you're currently using for data. Be really great, really helpful. So we already have a couple of messages from Rex and Nadim, so thank you very much. Thanks for joining there. Okay, so yeah, if anybody else joining as well, just say hello, that'd be great. And just wanted to check as well if everybody can hear me okay. If you can hear me, just say, yep, can hear you in the chat. That'd be great too. Cool. All good. So I can see here we've got some R users and some ClickSense users and some interest in some Python and stuff as well. So we can, definitely talk about a few of those things as well. Now, this particular presentation is basically taking a look at some of the tools and techniques which can be really, really helpful in a lot of different circumstances. But a lot of times people aren't always aware that some of these techniques are available. So these days, there is very much a focus on machine learning. Kind of machine learning is the new big thing right now. And it is an incredible set of techniques and that we can use to get more insight into our data. But with everything on the internet these days, you'd almost forget that there is a ton of other stuff available as well. And I was just having this conversation with my sister the other day, actually. And now she doesn't work in data. I was actually showing her a few Excel techniques, like just some things with pivot tables and different things like that. And she made this comment to me, which was something along the lines of, it's interesting actually because certain things like a count function and different things like that, you can kind of Google those or look them up because the function count, it kind of is somewhat intuitive that it would be used for counting something. But there's certain things that you would just never ever kind of think to look up in the first place because like for even something like a pivot table. If you've never heard of a pivot table, if you've never seen a pivot table, then it might not be completely intuitive or obvious that is something that you actually needed to learn or look up, as well as a whole bunch of other things as well. So even things like maybe data validation or data tables and different things like that might not be completely intuitive. So anyway, hopefully I will try and show you a few of those things today with R, and hopefully that will add to the kind of stuff that you do. Okay. So just a little bit of introduction about myself. So I've had the opportunity to work with various Fortune 500 companies. I run this YouTube channel that you guys are logging onto right now. So I've got a whole bunch of interviews here with like different data analysts and data scientists, as well as various tips and tricks. So there's a whole bunch of videos there, which I hope people will find helpful. So if you haven't subscribed already, definitely something worth checking out. I also run this website here, www.datastrategywithjonathan.com. So I do some basically training and consulting. And so far I've managed to reach over 12,000 students online, which is kind of cool. So Definitely worth checking that out as well. Okay. Now, I'm assuming here that, given you're working with things like R and stuff already, you're probably working with data frames, right? So data frames, or basically a table, is probably the most common data structure when it comes to working with data. But it's not the only data structure. So one of the first things I want to talk about is graph networks. So graph networks are really, really interesting actually, and they solve a whole bunch of different problems that data frames don't always solve that well. So if you don't know what a graph network is, this is basically what a graph network looks like here. These circles, basically known as nodes, and we've got these lines connecting these nodes. These are called edges, right? Which is basically the relationships between these different nodes. Okay. Now, just to give you a little bit of an idea of some of the different types of things that you can actually do with graph networks. So here you might have heard of a little search engine called Google, and this is the Google algorithm, the PageRank algorithm, effectively runs off a graph algorithm, right? So this is the PageRank algorithm up here. These different, the size of the nodes here represent the relevancy of different pages for a given search result. And you can see here that these are basically the links from different pages. So before Google came along, basically relevancy was based on the number of times a keyword appeared, right? And so that led to a lot of keyword stuffing and a lot of sort of somewhat irrelevant results. So once Google came along, they introduced this concept of ranking based on how many sort of links into your page. Now, we've got a whole bunch of links here, these purple ones and green ones here into this yellow one here, and so that this is a more relevant node here. And these nodes link into this big node up here. And so it's kind of somewhat intuitive that this node is quite large, and this is quite a relevant page because it's got lots of pages linking into it. Now, what's also interesting about this over here is that we have the second biggest node over here, this orange node C, doesn't have a lot of links into it at all, but it's still very relevant, and it's a lot more relevant because it has a very important link into it from this node here, node B, right? And so that's the way that it kind of weights that. Now, this is the PageRank algorithm, but the PageRank algorithm is basically just a centrality algorithm. And we have like a whole bunch of these, and they're, when you're working with graphs, these are basically kind of functions that you pull out to be able to do these types of things. And they give you, the importance of different types of nodes. So, for example, if you move across to something like a social network, you may want to find who are the most relevant people within the social network. And that could be based on a whole bunch of different types of things. That could be based on how many people that, that somebody is connected to, or it could be based on something like some sort of bridge builder, someone who connects like two very large networks. So different things like that you could take a look at. So other things here, we have other applications of graphs. We have things like route finding. So if you're working with any geospatial data, something to take into consideration is maybe whether if you could use something like a graph in order to carry out your analysis. So it can be used for things like route finding, shortest path. These are effectively graph network algorithms. And this final one over here, we have recommendation engines. So Amazon and Netflix, a big part of what they do is based off recommendations. And so, if person A likes a whole bunch of movies that person B likes, then you can find those relationships and find the things that they haven't watched and be able to get recommend those as well, right? Now, one of the key things that you'll notice which is different about a graph network structure compared to your regular data frame table structure is effectively that there's a lot more emphasis on the relationships. So basically these lines. So these lines that connect the nodes are just as important as the nodes themselves. Whereas normally within a data frame or any type of table, each node effectively represents a record. And that is the primary focus of what you are actually looking at. And so what happens is if you are trying to build something or query something which does have lots and lots of relationships, then that just doesn't really work very effectively with tables. I mean, obviously with tables you have things like joins, which kind of brings me on to my next slide here. Okay, now this is an example of a graph query. So find all direct reports and how many people they manage, each up to 3 levels down. So this was kind of going back to, say, the first slide. Here we have some organizational structure. This can be many, many layers deep. Now you don't necessarily know how many layers deep this is. And so you could be getting into a lot of recursion in order to be able to write all these different types of queries. With graph type queries, you can do this very, very efficiently. So here we have a graph query. This is using a query language called Cypher, which is part of Neo4j, which is quite a cool graph network database. If you are actually looking to learn more about graphs, then it's a great place to start because there's a lot of graph theory that gets quite academic sometimes, and you might not see the relevance of some of the different algorithms, but Neo4j has a lot of case studies that kind of puts it into business context, which is really nice, and they have a really nice database as well. You can use Neo4j or connect to Neo4j from within R using the R Neo4j package, or you can actually just work directly with graphs in R as well using some packages like iGraph and Viz Network and tidygraph, which I'll show you more of in a sec as well. So basically you can see that really short graph query equals really, really long sort of SQL query, which has lots of horrible recursive joins and all this kind of thing, right? So, and not only is this much more concise and easier to read, easier to understand, it also performs basically thousands of times faster just because of the way the data structure is actually organized. Okay. So this is a graph network application that I built for a client a little while back, or an example of it anyway. As you can see, this is all using Star Wars data. So just some made up data over here. But effectively, this represents an organizational structure. So, and this organizational structure allows you to explore different queries like I was just showing off before, about, maybe, let me give you a little demo of what this kind of application looks like anyway. So if each of these nodes represents a different employee within your organization, you've got different relationships between different employees. This is a sort of hierarchical management structure like so. You can flip around the different attributes of this. You can see all the different colors here, which you can change to make different categories. You can zoom in and add different attributes to the node, so you can zoom in and see different details about each of the people within this network. Okay. So another piece of work that I did with this actually was with the visualization of large networks. So here, I just got this little slide here. And this is an example actually, not just of kind of graph networks, but also some of the kind of applications that you can actually build with R as well. So this is using the Viz network library within R. And this is basically me adding different nodes to this graph. And what this is actually really kind of demonstrating, besides this kind of flashy visualization here, is these nodes actually being rendered on the server and actually being passed through to the application without the page having to refresh at all. So this is kind of all happening in real time, which, I think is kind of cool. Cool. Now this is basically 1,000 data points here. Now, if you were to view this in a table, this would, you probably wouldn't be able to see 1,000 records on the screen at the same time with something like a table. But here with the node, you can kind of see this, and you could add, like extra layers onto this, different colors and sizes and different things like that to represent different information. So you can get some idea about structure. But when you're getting to larger networks, like over 1,000 nodes or so, then the problem you end up with is something like this. So this is known as what's known as a graph hairball. And a graph hairball basically doesn't really give you necessarily that much insight about your actual data. So I actually came up with a few methods for actually visualizing larger data sets. So when I was working with this particular organization, they're quite a large organization. They have around 250,000 ish employees or so. And you just really can't visualize that much data by just drawing on every single point. So I think we've had a few other people join as well. So hey there to Anthony and Binyam. And thanks for the comments there. So now this here was one of the solutions I came up with for basically visualizing the entire organization of over 250,000 people. And what's happening here, this application is basically aggregating the number of employees into different groupings that you dynamically select from some of these different drop downs here. And so some different applications of graph network analysis, which I think are kind of useful. Okay. Now, one thing I wanted to point out as well is that if you've worked with some R, then this is basically, you might recognize this as a Shiny application. Shiny is basically this way of very, very rapidly building these kind of interactive web applications without having to know any HTML or any JavaScript. Now, if you've been using R a bit more as well, then you might have used things like R Markdown. Now, this is what R Markdown looks like here. If you've used Python and stuff as well, Python is really, really popular these days. And probably the key way for learning Python these days seems to be in Jupyter Notebooks. So that's the way that a lot of instructors are teaching people how to use Python. Now, if you're familiar with that, then an R Markdown document, like you see here, is it's kind of similar to a Jupyter Notebook, but it has some really, really cool advantages as well. So here I have this output, which is an HTML document. And if I basically change this, I can render this as an HTML, or I can just, if I want to, I change this into a Word document. It completely re-renders there. I can take this, I can turn it into a set of slides. So this is what some of the slides look like there. And you could do this as PowerPoint and stuff as well. And one of my favorites is this right here. So this is a Flex dashboard. So this is an interactive dashboard basically made from a markdown document, right? And you can see when I drag it across here, everything automatically rescales, resizes. So this is basically mobile phone friendly, right? So a pretty neat little thing over there. And so all the applications I was showing you earlier is basically an application, basically an example of what you can do with something like a Flex dashboard. Now, this is the next thing that I think is massively underutilized when coming to use something like R. Because here's the thing: one of the things that's really important is that when you are, when you do your analysis in R, it's one of the things that can really get quite technical. Like if you're just seeing screens of code and you want to get that and give that to a client, you want to be able to demonstrate, you want to show the value of your work, you want to be able to quickly put stuff together, then you really want a nice way to present that as well. Now, as I mentioned, Shiny is great. It's fantastic. You can build all these web applications. There is one downside of Shiny is that you also need to have a server to actually host these kind of things. Now, this is the nice thing about a Flex dashboard is that, excuse me, sorry, it can work with or without a Shiny server. So let me give you a little demo here of how you can set some of these things up. So here I'm in RStudio. I've got a blank document here. I'm just going to type in this little shortcut here. So I've just typed in these 3 letters here, and I'm going to hit the tab key, and it basically auto-populates all of this code for me here. Now, how did this work? If you come over to here, Tools, Global Options, under Code, there's a cool little thing here called Snippets. I don't know if you guys seen this before, but basically on the snippets, you can have all these little code chunks that you can just type in a couple of letters like EL and then hit the tab key, and it's going to automatically type these things for you. So I've basically added my own down the bottom here. This is the FDS one, which I just typed in, and it will basically automatically type all this code for you, which is really handy. And at the end of this as well, if you want to download a copy of this code, I'll have a link for that as well, where you can go ahead and download and get access to all of that. Okay. So anyway, here is the code which has all been populated here. I've got this one parameter data. I'm just going to chuck in a sample data set. And I'm just going to run this using the Control-Shift-K button. I'm just going to save this as demo.rmd. And when you do this, do make sure that you save it as an RMD file. And that's what this warning is here instead of a .r file. Otherwise, because it needs to know it's the file type in order to be able to render this. Okay. And I just want to point out as well that this particular template is actually specially designed to work with any data set. So I typed in the Star Wars data set, but you can just simply add your own data. You don't actually have to change any other parameters in the entire document other than basically the data set. So it gives you some charts here, a data table here with like options to download it in different formats here. I can change this. This is automatically populated by all of the different data points in the data set. You can change the different metrics here, right? And that dynamically redraws. Okay. Cool. So that is a Flex dashboard. So a very, very handy feature there. Okay. So if you wanted to download some of the examples that I've shown here, so I've got some code examples for some of the graphs and different graph code that you can use there, as well as some examples for the Flex dashboards as well. You can see that at www.datastrategywithjonathan.com/p/UCL. So this is a presentation I'm actually putting together, which I'm going to be presenting at UCL in a few weeks' time. So if you are in London, then definitely do come and check that out. But yeah, you can download some of the examples there. So let's see some of the questions that we have here. So if you have any questions, any feedback, any thoughts on any of this, do please let me know. So Anthony, I'd love to figure out how to pump in a bunch of surveys I have and see a readout by language that people mention, as well as profession, age, and other stats. Okay, that's interesting actually. So I've got a few friends actually who I've interviewed on on my YouTube channel as well, and some of them actually specialize in working with survey data. So one of my friends, Martin Chan, who came on a little while ago, he uses a package called RQDA, which is quite specialized for working with survey analysis. But I think for the most part of it, it's a lot of the questions, probably have a few aggregations around there, some different things like that. I think that should kind of do the trick. The interesting thing about surveys is that sometimes you have a lot of different questions, and sometimes you're having to group those up into sort of subcategories. So, yeah. Cool. And just going back to the chat, before we got started, I think I had a question from Rex as well. He was mentioning a few things about, so he's studying R in university, and he was interested in Python as well, because he was mentioning that they teach Python at his university, but not for things for machine learning as much. It's more for general programming. So it's interesting that because Python is a general purpose programming language. So as a first programming language, it's quite a good programming language to get into. It does everything from programming your Raspberry Pis to which are kind of little hardware devices, to maintaining sort of different cloud-based servers, to be able to do stuff like machine learning as everything as well. So the interesting thing is, so R is a more kind of specialized language, especially if you're learning stats. That was the original intent of R, was to provide a programming language for teaching statistics. It's been around, R has been around for I think 20 plus years now. And so it's very, very well developed in the data field. Python is actually been around for a lot less time in the data specific field, but has had a massive adoption lately. I think thanks to things like Jupyter Notebooks, as well as the fact that a lot of the big tech companies such as Google and Facebook are developing a lot of stuff for machine learning for Python. There is one thing that I think is worth pointing out though as well. Both languages are very popular. Python's got a larger user base because it does other things besides data. Both are definitely good skills to learn. The companies like Google and Facebook and everything like that, who are doing a lot of the more advanced machine learning stuff like deep learning, neural networks, and all these kind of things, like Google building out TensorFlow. And these are some of the focus of these kind of things is more for building applications. So things like your Apple Siri or Amazon Echoes, chatbots, maybe computer vision, all these kind of things, which is very, very cool. Whereas some of the stuff that you can do with R, like I just showed you, these applications using Flex dashboards, these are, I would say, more kind of, if you're working with businesses which have more traditional types of data, like a lot of stuff in Excel spreadsheets or databases, just your general systems, then R deals with those very, very efficiently, very nicely. The code, there's far less code involved. You could be like a business analyst, a business consultant, something like that, and work with R for those kind of things, and probably get the job done in at least half the time that you could with something like Python for these specific types of applications, because of some of the things like Flex dashboards. Now, you're not going to get as much control. I mean, I probably wouldn't be building something like a computer vision application with a Flex dashboard. I would probably just move to something like Python for that, because it's just got more support there. But that's the thing I really wanted to point out, that R and Python are both really, really good and powerful languages, but for slightly different applications. There's a lot of overlap, but they are basically stronger for different types of applications. Cool. Do we have any other questions here from anybody who's anybody here? Cool. All right. So anyways, I hope you guys found that useful. Let me know what's coming next in big data. So thanks for that question. I think that's an interesting one there. So I think big data is an interesting one, because I think that a lot of what people think of as big data isn't necessarily a big data. So especially if you're working with tools like on a laptop, a lot of times you have people working with Excel, and once you get past a few tens of thousands of records, it seems to feel like big data or something like that. Then you get people working with R, you're working on a laptop or something like that. Maybe you can get to a few million, right? And that's definitely not kind of big data either. Even with something like R, if you're using something like a library called data tables and you get a more powerful computers have gotten a lot more powerful these days. You can easily handle billions of records just using like r.datatable, which is pretty impressive there. Now, a lot of times when people think about big data, they're thinking about things like Hadoop. Now, Hadoop was effectively based off a technology built by Google, which was used to index the internet. Now, that is big data, right? When you think about how big and massive the internet is. And there's a lot of data which is like highly unstructured. So structured is the type of stuff that you kind of get in databases and Excel spreadsheets. Unstructured is things like pictures and videos and or log files or different things like that. It doesn't have a very good structure to it. Now, because these files are so much larger, they make up the majority of data on the internet, right? You just imagine YouTube, basically. And so I think that a lot of people don't actually need to work with big data at all. Especially since computers have gotten so much faster now, you can just do stuff basically off a laptop these days that you couldn't do before. these days, if you are getting into big data, probably some of the key words that you might have heard of are things like Spark. So Spark is Spark is a distributed data frame, right? So if you worked with R, you've basically worked with data frames. But to me, big data is when the data is too big to fit on one computer, and computers are pretty big these days. So Spark is interesting technology worth looking into as well. But like I said, if you got like less than 1 billion records of data, and then you can still use something like R, and Spark doesn't really help that much. So, yeah. So, and I will be planning some other videos on some big data topics and stuff as well. Hoping they actually get somebody in who's actually written a book on some of the myths about big data as well. So we'll watch this space. Hopefully we'll get that in too. Okay. So, yeah, that's all right. So we're just finishing off now, actually. But there will be. I'll leave this on replay for probably the next 24 hours or so, if anybody wants to watch this. And but yeah, definitely go ahead, download the resources, and let me know if you have any other questions. So, cool. Okay, we'll catch you guys later.